Hey, what's going on, guys? Let's do this problem right here. The question is asking let a is equal to this value, and if a is invertible, then determine its inverse. So first of all, we have to find whether a is invertible, or also we have to find inverse. So when we do the Gauss Jordan, it will automatically answer both of these things. So first of all, let's do this. So I copying this matrix right here. So it's going to be 1 0 1 2 1 3 1 0 2. So this is my matrix. And first of all, so to bring with the Gauss Jordan, I had to eliminate, I had to bring all the values below pivot is equal to 0. So in this case, the last one is very easy. I can multiply the first one by -1 and add it to the last one. So it's going to be, this remains the same. And the last one, so also I can do the inverse too. So to do the inverse, I have to take Gauss Jordan pattern right here, and when I change this one into Gauss Jordan, this will become my A inverse. So let's see, 0 1 0 and 0 0 1. So this is gonna change when I do this one. So let's see how it's gonna change. So this is I'm multiplying the first equation by negative and adding with the third equation. So it's going to be negative r1 plus r3, which is going to be 0 right here. Negative 0, so negative times 0 plus 0 is going to be 0. Negative 1 plus 2 is going to be 1. And in this case, negative 1 plus 0 is going to be negative 1. And I copy 1 0 0 0 1 0 0 0 1. So negative 1 plus 0 is negative 1, 0 plus 0 is going to be 0, then 0 plus 1 is going to be just 1. Now we reach the Gauss-Jordan pattern in the bottom. Now we have to eliminate the second one. To eliminate this second one, I can multiply this one by -2 and add it with the third equation, second equation. So if I do this one, I will get 1 0 1 1 0 0, and if I multiply the first equation by -2, it's going to be -2 r2, first equation -2 r1 plus r2, which is going to give me 0 right here, and we are going to have 1 here, and this is going to become -2 plus 3 is going to be 1, and at the end we have -2 times negative 2 times 1 is going to be -2, so therefore it's going to be -2, and then 0 plus 1 is going to be 1, and 0 plus 0 is going to be 0. Then at the end we are going to have the same thing. It's going to be 0 0 1 minus 1 0 1. So let's continue here. First of all, now this is almost good. Now I have to eliminate the third column in the first and second row. So let's see how we can do this. So first of all, I eliminate the first one. So 1 0, and to eliminate this one, I multiply the third equation by -1 and add it to the first equation. So it's going to be negative r3 plus r1, which is going to give me 1 0 0, and here we are going to have negative 1 is going to be positive 1 plus 1 is going to be 2, and here we are going to have 0 plus 0 0, and negative 1 plus 0 is going to be -1, and the second one is second I can do in the same thing. So it's going to be negative r3 plus r2, which is going to give me 0 1 0, and in this case we are going to have negative negative 1 is going to be positive 1 plus -2 is going to be -1, then 0 plus 1 is going to be 1, 1 plus 0 is going to be just 1. Then the third column is going to be remain the same, 0 0 1 minus 1 0 1. So if A is invertible, then determine its inverse. So first of all, we have to show that A is invertible because the determinant is not equal to 0. If you see the multiplication of diagonal is going to be my determinant, because this is upper triangular and lower triangular. So whenever you get something like this, if you multiply the diagonal, that's going to give you the determinant. In this case, if you multiply this diagonal, that's not going to be equal to 0. Therefore, this is this is invertible. And they are asking for the inverse of the A inverse is going to be this value. So it's going to be A inverse is equal to 2 0 minus 1 minus 1 1 1 and minus 1 0 1. This is my final answer. I hope you guys like this video. See you next time.